Welcome back. We're going to continue on with another strategy called the proportion. So we just talked about, multiplying and dividing are really close related. And these are going to really tie into this lesson as well. So when we talk about proportion, one of the things we learned is in a proportion, the cross products of a proportion are equal. So if you set two fractions equal to each other, that is going to represent a proportion. Only if those cross products are equal. So for instance, 2/4 is equal to 1/2. This is only going to be true is if the cross products are equal. So if I multiply 4 times 1, that must equal 2 times 2. So since 4 times 1 does equal 2 times 2, because they both equal 4, that is a proportion. So to be a proportion, those cross products have to be equal. So if you notice that this example right here, I did set a fraction equal to a fraction, but this is not a proportion because if you cross multiply, 2 times 3, does that equal 4 times 1? Well, that's 6 and that's 4. That's not a true statement. So that's not an example of a proportion. Those two fractions are not equal. What's kind of cool though is if you're comparing fractions, notice how 4 times 1 gave you 4 and 2 times 3 gave you 6. Notice how that 4 goes up to 1/2, that 6 goes up to 3/4. That 4 and 6 can actually tell you not only they're not equal, but it also tells you who's bigger. That 6 corresponds to 3/4, so that's telling you actually 3/4 is bigger than 1/2. Now, for our purposes, though, let's look at, again, this example here. 5/8 has to equal 15/24. If the cross products are equal. If those cross products are unequal, then this is not a proportion. So we're looking to verify 8 times 15. So 8 times 15, I can break that as 8 times 15 is 10 and 5. So I can use that rectangular model to multiply, which we call that distributive property. 80 plus 40. 8 times 10 is 80. 8 times 5 is 40. That'd be 120. 24 times 5, well, that'd be like 5 times 20 and a 4. 5 times 20 is 100. 5 times 4 is 20. That's 120. So that tells me that these two cross products are equal. That means that this was indeed a proportion. So if I look at this problem right here, we want to make this a proportion, which means we want this to be a true statement. So what we're trying to figure out is 8 times what number is the same thing as 10 times 10. So 8 times what number is the same thing as 10 times 10. So if I play this out, use my cross product, what this says is 8x has to equal 10 times 10, which is 100. So 8 times what number is 100? Don't forget, in this problem, we can think backwards. And since we see multiplication, we can think backwards and use division to solve this problem. So I can look at this as 100 divided by 8. So x is going to equal 100 divided by 8. Now I really can't divide 100 by 8 very easily, but since these are both even, I can divide them both by 2. I can rename this fraction or this division problem to being 50 divided by 4. And I can even take that a step further because those can both be divided by 2 again. I could change that to 25 divided by 2. And so I could leave that as an improper fraction as an answer, or I could divide 2 into 25. So 2 into 25, 2 would go to 2 one time. Remainder is 1, slide that 5 down. 2 goes to 15 7 times. 7 times 2 is 14. Remainder of 1, so I can say 17. Let me see, that's not quite right. That should be 0. Let's back that up. That ain't making sense. So 2 went into 2 one time with the remainder of 0. 5 slides down. 2 goes into 5 twice. 2 times 2 is 4. 5 minus 4 is 1. So I could say 12 and a half. So your answer could be 25 halves, or you could say 12 and a half. So again, we're trying to figure out 12 times what number is the same thing as 6 times 10. Well, 6 times 10 is 60. what times 12 is 60? If you see 5 there, then you're done. X equals 5. If you cannot see that 5, we are allowed to what we call cross multiply as a strategy. So we can say 12 times x has to equal 60. Again, since I have multiplication, I could see this in a reverse direction. I can see this as a division problem to find that answer. So x is going to equal 60 divided by 12. Again, I'm not real good at dividing by 12, but since those are both even, I could divide by 2 and say, hey, that's the same thing as 30 divided by 6. That's actually doable for me. 6 goes to 30 5 times. So x would equal 5. So this next problem looks like I'm going to need a little bit of stretch work again, so let me clear this out of here. So in this problem I have decimals. 7.7 divided by 3.6 equals 2.3 over x. Again, I could manipulate this by saying 7.7x equals 2.3 times 3.6. 2.3 times 3.6. And our strategy we've learned is I can kind of remove the decimal out of the problem and just focus on 23 times 36 and do that math. And again, if I want, I can use the rectangular model for that. 23 is like a 20 and a 3. A 36 is a 30 and a 6. So I can go 20 times 30 is 600. 2 times 3 is 6, stick on the zeros. 20 times 6 would be 120. That's like saying 6 times 2 is 12, add a 0. 3 times 30 would be 90. And 3 times 6 is 18. So that would be 720 plus 108. Therefore, I'd have 828. And since I removed 2 decimal places, I've got to put those 2 decimal places back in the answer. That would be 8.28. So it's going to be 8.28. So now we've got to figure out is what's 7.7 times what number is going to give me 8.28. Again, what I can do is kind of go backwards and divide out. So I could say x is going to equal 8.28 divided by 7.7. Now, a creative thing with fractions is I don't have to deal with dividing by decimals because I can rename fractions, and we've learned that if you multiply by 10, that slides the decimal place one place to the right. So if I wanted to, I could change this to 828 divided by 770. Because if I move the decimal 2 places on the top, I've got to move the decimal 2 places on the bottom. And now I've got a problem that looks like this. Now since they're both even, I could divide out, but that don't look like that's very friendly there. I may have to go old school on this and just do 770 into 828. I do know that 770 goes to 820 just one time. Subtract, I get an 8 there, got to borrow, get a 5 there, 58. So I would have 1 and 58 770s. Or again, I can probably reduce this by dividing out of 2. That's going to change that to what, 24, 20, no, 25, 26, looks like 29. And then I got to divide that 770 by 2. Running out of room. So 770 divided by 2. A lot of math here. So we end up with 3 goes there. Remainder 1. 2 goes to 17 8 times. You get a remainder of 1. So I get a 10. It looks like a 5. So that means that's going to be 385 on the bottom. So you could say that answer is 1 and 29 over 385. So sometimes in math we just don't get very clean numbers. We just got to do the math, and that one challenged us a little bit as far as paperwork goes. Let's look at this last example. So again, my strategy for proportion is I'm allowed to cross multiply. So I have, and I always like to multiply the one that's got the variable. I guess since I'm solving for x, let's just change that to an x there. So that would be 30x equals 10. And then I got to divide, so x is going to be 10 divided by 30. And I can just mark those zeros out, because that's like dividing by 10. Dividing by 10 just means to drop a 0, or move the decimal one place left. And that would turn into a 1/3. So 1/3 would be the answer to that problem. So again, not all numbers are going to be nice and clean. We will have, and again, some of these I could have changed to decimals. So instead of saying 12.5, I could have said 12.5. 1/3 would be some type of hidden decimal, and I'm not really sure what that one would be. Okay, so there's the power of proportion. And we're going to be using proportions quite a bit to solve percent problems. So stay tuned.